Welcome back to All This Math. This is Professor Parker, and for this next lesson, we're going to talk about, or actually do an example where we solve a double absolute value equation using the table of intervals method. The table of intervals method. Of course, another way to solve these would be to just basically set up the equation whereby you're solving for one of the absolute values, and then you're going to end up creating your two equations based on that, but you're still going to have another absolute value in each of those equations. So then you would then in turn solve for those two equations. So giving you a total of 4 equations altogether. All right. But we're going to use the table of intervals method where we're not going to actually do it the way I just explained. Before we get started, I definitely want to pay homage and shout out the sisters whose names are on this hoodie: Harriet Tubman, Asada Shakur. See my picture of Asada Shakur right here. Fannie Lou Hamer and Ida B. Wells Barnett. So if you're familiar with those sisters, cool. Continue to learn about them and the work that they did and the communities they were a part of, and the institutions they were a part of, and the writing that they've done. If you're not familiar with these sisters, definitely get familiar as soon as possible. All right. Now let's get started. So we got the absolute value of x minus 2 plus the absolute value of x minus 7 is equal to 5. We're trying to solve. This is an equation we're trying to solve. We want to know what value of x makes this equation true. And there's going to be multiple values of x if there are any values at all, because sometimes there will be no solution. In some of these problems, there will be no solution, right? So we're going to see what happens. The first step in these problems, right, is to find what I call turning points. Some people may call them, or teachers or professors may refer to them as breaking points, but I call them turning points, all right? The way we find the turning points is you take each of the expressions that are within the absolute value and you solve for x, right? You set up an equation that's equal to 0 and you solve for x. Again, you set up equations that are equal to 0 and solve for x, all right? So we're going to have x minus 2 is equal to 0, and we're going to solve for x. And then we're going to have x minus 7 equals 0, and we're going to solve for x. All right, so if x minus 2 is equal to 0, we know by adding 2 on both sides of the equation that x is equal to 2. All right, and if we have x minus 7 is equal to 0, we know by adding 7 on each side of the equation that x is equal to 7. So 2 and 7 are our two turning points, essentially. All right, basically that's where that gives you 0. So it's kind of difficult for me to explain, actually, but it has to do with where the equation goes from being negative to positive, because 0 is the boundary between negatives and positive. If you visualize the number line, this method really does require you to visualize the number line, because it's based on the concept of a number line where you have 0, all your negatives to the left, and then all the positives to the right of 0. All right, so these are our turning points at 2 and 7. Now we create our table. We create our table now. Now, because we have two absolute values, our table is going to have 3 intervals. 3 intervals. All right. So I'm going to do my little table up here. All right. Now, again, this is based on the number line. It's based on the number line and the logic of the number line. So negatives are to the left, positives are to the right. So what you want to do is your first interval to the far left is going to go from negative infinity, because we're basing it on the number line, from negative infinity to the smaller of the 2 points. All right, so we're going from negative infinity to 2. All right, now, of course, negative infinity is never included. That's why there's a parenthesis next to it. And in this case, in the first interval, I never include the boundary point to the right, at the end of this interval. All right, but I am going to include it in my next interval. So my next interval, I go from 2 to the next bigger turning point, which is 7. But 7 is not included, right? So I go from 2, which is included, to 7, but the 7 is not included, all right? So then in the next interval, I'm going from, and I am going to include the 7 here, I'm going from 7 to infinity. So this is how you set up your table, all right? I got 2 turning points, so that means I'm going to have 3 intervals. I go from negative infinity to positive 2. I go from 2 to 7, where 2 is included. Some people, and if you do research on other YouTube channels and look at other teachers or whoever, other tutors or whatnot, content creators, what have you, they will not include the 2, right? I like to include that first point, that point to the far left, though. I like to include it, though, and also in here. But some people don't include it. But you can get the final answer, you can get the correct answer without including it. I learned to do it this way, so I'm sticking with it. So you go from 2 to 7, include the 2, 7 to infinity, include the 7. All right, next step. We got to look at our absolute values. Look at our absolute values. So what you want to do is we want to know when we rewrite our equations, because ultimately we're going to create 3 equations. 3 equations. Why 3 equations? Because we got 3 intervals. So when you're doing these types of problems, you're going to have as many equations as you have intervals. So since we have 3 intervals, that means we're going to have 3 equations. If we had 4 intervals, we would have 4 equations. And we might have 4 intervals in another example if we had 3 absolute values. If we had 3 absolute values, then we would have 4 intervals, and it would just make sense. Because look, we got 2 absolute values, and that gives us 3 intervals. So there's always going to be one more interval than there is the number of absolute values. So when we create our equations, we want to know, is this x minus 2 going to be just plain positive x minus 2 as an expression, or is it going to be negative quantity of x minus 2? That's the question we got to ask. And we also want to ask the same thing about the quantity of x minus 7, right? Now, how do we figure that out? And think back for a minute, too. Think about like if you was just doing the absolute value of x minus 7 equals 5. You would set up 2 equations. You would have x minus 7 equals 5, whereas you leave x minus 7 as positive. It's the same thing, just plain x minus 7. And you'd have x minus 7 is equal to negative 5. All right? So you'd have the 2. So basically what we're doing here is we're saying, is it going to be positive or is it going to be negative? Is it going to be a positive x minus 2 or is it going to be a negative quantity x minus 2? Is it going to be a positive quantity x minus 7 or is it going to be a negative quantity x minus 7? The way we figure that out is you go to your interval. You pick any number in that interval. And again, this is based on the number line. So from negative infinity all the way to positive 2. Think of the number line. Try to visualize a number line. So you pick any number in that interval and then you throw it in there. And then based upon what value you get, if that number is positive or negative, we'll tell you whether you should have positive x minus 2 or the negative quantity of x minus 2. All right? So what I'm going to do is, I know that 0 is in between negative infinity and 2. So I'm going to just use 0. I'm going to use 0 because it's in that interval. So I throw 0 in here, right? And I do 0 minus 2. 0 minus 2 is negative 2. That's a negative. So if you end up with a negative, then that means we're going to use the negative of this expression. So we got negative quantity x minus 2. All right? That's what we got. The negative quantity of x minus 2. Then we do the same thing for x minus 7. I'm going to use 0 again. I'm going to use the same number. You can use a different number if you want, I guess, as long as it's in that interval. But why not just use the same number? So I'm going to do 0 minus 7. I get negative 7. I get a negative again. So that means because I got a negative, I'm going to use the negative quantity x minus 7. All right? So I got negative quantity x minus 2 and negative quantity x minus 7. All right? Now I got to do the same thing for this interval and this interval. So I'm going to end up with a total. I got to do this a total of 6 times. I've done it twice, so I got to do it 4 more times. So now I pick a number in this interval between 2 and 7. Now I could use 2 since 2 is included. So yeah, I might as well use 2 since 2 is included in this. So 2 minus 2 is 0. Right? Now, here's the thing. We treat a 0 like a positive. So if we don't get it, we either get a negative or a non-negative number. Non-negative, of course, is 0 or positive, right? Non-negative, they're not negative. So if we get a 0 or a positive, then we keep it the same. We just use regular x minus 2. So we got x minus 2 right here. Now, do 2 again. 2 minus 7. 2 minus 7 is negative 5. Negative 5. So because we end up with a negative, we're going to take the negative of this expression. So negative x minus 7, right? Now, we go to this third interval from 7 to infinity. From 7 to infinity, I could just use 7, right? Because 7 is included. 7 is not just a boundary point. It's included, just like the 2 is included. That's what the bracket means. Don't forget what the bracket means versus the parentheses. Parentheses means it's just a boundary point and it's not included. The bracket means that number next to it is included in the interval. It's not just a boundary point. All right? So if I use 7 in this interval, I'm going to have 7 minus 2. 7 minus 2 is 5. 5 is a positive number, of course. So that means I'm going to just have regular x minus 2. And what this is for, in case you're wondering, okay, well, what is this for? Why am I doing this? Because these are the expressions you're going to use when we create our equations that we're going to solve. And then in turn, we're going to take the solutions and decide whether we accept them or reject them. Now, how do we know if we accept or reject them? You accept them if those solutions you find from your equation that we're going to create 3 of them because we got 3 intervals, so 3 equations, if they are actually indeed in this interval. If it is in that interval, then we accept it. If it's not in the interval, we reject it. All right. So over here, what did I use? 7? Yeah, 7. So 7 minus 7 is 0. So we treat a 0 like a positive because it's non-negative. It's either negative or non-negative, negative or non-negative. So we get 0 when we do 7 minus 7. So that means that we just use x minus 7. Just plain old x minus 7, you know? All right. So now it's time to set up our equations. We're going to have a total of 3 equations. The first equation is going to be based on this interval. The second equation is based on this interval. The third equation is based on this interval. So I'm going to go over here and I'm going to write negative quantity x minus 2 plus negative quantity of x minus 7 is equal to 5. That's my first equation. My next equation is going to be x minus 2 plus the negative quantity of x minus 7 is equal to 5. That's my second equation. My third equation is going to be x minus 2 plus x minus 7 is equal to 5. And then I'm going to solve all 3 of those equations. And then I'm going to decide if I'm going to accept or reject the solutions that I get, right? I got to decide that. Now, how do I decide that? The way I decide it is whatever that number is, I'm going to test it to see if it's in that interval. So in the first equation, if I get a number that's in this interval, then I accept it and it's cool. If it's not in that interval, then I reject it and it's not cool. All right. All right. So let's go. Let's do first equation, negative quantity x minus 2 plus negative quantity x minus 7 is equal to 5. So that's my equation. Negative quantity x minus 2 plus, because that's a plus sign, the quantity of, I use brackets, right, to separate the plus sign from the negative sign, because that's negative quantity x minus 7 is equal to 5. Then I start simplifying, and then I ultimately solve for x. So watch what I do. I'm going to have negative x plus 2, because of the double negative. Then I'm going to have plus the quantity negative x plus 7 is equal to 5, right? And then I'm going to have negative x plus 2 minus x plus 7 is equal to 5. So look what I got here. Negative x plus 2 plus the quantity negative x plus 7, because that's negative x, and that's a double negative, negative 7, which gives you plus 7, and equals 5. And then I drop the bracket, so now I got negative x plus 2 minus x plus 7 equals 5. I'm going to combine these negative x's. That's going to give me negative 2x. I'm going to do the 2 plus the 7. That's going to give me 9 is equal to 5. And then I'm going to do minus 9 and minus 9. Boom, 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 boom. Negative 2x is equal to negative 4. Divide by negative 2 on both sides. And I got x equals positive 2. X equals positive 2. So look at the algebra. Negative x minus x gives me the negative 2x. The 2 plus the 7 gives me the 9. I subtract 9 on each side. I got to maintain balance like Mayat, ancient Kemet, right? Subtract 9 on the left, subtract 9 on the right. I got negative 2x equals negative 4. I want to get rid of the negative 2 so I can isolate x by itself. I divide each side by negative 2. I get positive 2. Now, this is when we do our test. We're going to test the solution to see if it actually does solve the equation, right? Because we don't want to end up with solutions that don't solve, like Dr. Martin Luther King said, and also later Fred Hampton said, right? We don't want to end up with solutions that don't solve. So we go to this interval and we say, is 2 in this interval? Now you got to be careful with this, right? What does this parenthesis mean? This parenthesis means that 2 is a boundary point, but it is not in that interval. 2 is not included in that interval. 2 is only a boundary point. So therefore, if we're saying x is equal to 2, we reject this. We reject this solution because 2 is not in that interval. It's only a boundary point. There is not a bracket next to this. There is a parenthesis next to this. 2 is in this interval over here. 2 is over here, right? But you'll see something interesting that happens because look, check this out. If you did substitute in 2, 2 minus 2 is 0, 2 minus 7 is negative 5. 0 is just 0. Negative 5, absolute value becomes positive 5. 0 plus 5 is in fact 5. So while I do reject x equals 2 in this interval, let's see what happens. Makes more emphasis on that. Let's see what happens when I create the equation for this second interval. Let's see what happens and see if we still end up with 2 as one of our solutions. So let me write my equation. My equation is going to be x minus 2 plus, because that's a plus sign, the quantity, negative quantity x minus 7 is equal to 5. All right, so then I'm going to have x minus 2 minus x, that's a double negative. So that's going to be plus 7. You got to be real careful with these negative signs, man. You can get caught up, man, if you're not careful. All right, because that's negative x, boom. So plus a negative is just minus x. And then that's a double negative, so that's positive 7. So that's plus positive 7. All right, cool. So now what we do is, okay, combine the x's. They cancel out. Negative 2 plus 7 equals 5, and 5 equals 5. So 5 equals 5. So that means, so this is a true statement, right? The variables cancel out, and you're left with a true statement, right? So what that means is, whenever you encounter that, that means that every value in this interval, because we end up with a true statement, and it's kind of similar to when you're solving an equation and you get this scenario, that would mean that there's an infinite number of solutions, right? That's what it would mean. There's an infinite number of solutions. When we're dealing with a double absolute value, or even a triple absolute value, or quadruple absolute value, if this happens, then what you end up doing is saying, okay, all the values in this interval are solutions. So look what happens. That 2 still ends up being, because there's a bracket next to the 2. So in this interval, 2 is included. 2 is included in this interval, right? So we would say all solutions in this interval, or something like that. All solutions in this interval. So from 2 to 7. So this is no good. This is good. From 2 to 7. Let's test it, right? We already know 2 is the solution, so that's good. What about 3? 3 minus 2 is 1. 3 minus 7 is negative 4. That's 1. That's 4. What's 1 plus 4? 5. Because the absolute values, right? 1 plus 4 is 5. What about 7? Let's go up to 7. 7 minus 2 is 5. 7 minus 7 is 0. What's 5 plus 0? 5. So this is good. Everything in this, and actually, no. Matter of fact, no, 7 is not included. 7 is not included because 7 is not in this interval. 7 is a boundary point. I shouldn't have said 7. 7 is a boundary point. But what about 6, right? 6 minus 2 is 4. 6 minus 7 is negative 1. Absolute value gives you 1. 4 plus 1 gives you 5. All right? So 7 is not included in this interval, right? Because 7 is a boundary point. All right? Now let's do the third equation and see what happens. So let's do x minus 2 plus x minus 7 is equal to 5. Combine your x's, that gives you 2x. Combine your negative 2 and your negative 7, negative 9 equals 5. 2x is equal to 14. X is equal to 7. Add 9, get 14. Divide by 2, get x equals 7. 2x divided by 2 is just x. X is 7. So, is this in this interval? It is. Because in this interval, 7 is included. In this interval, 7 is included. So x equals 7. So we accept this. All right? So what happens is, so from 7 to infinity, all right? So what if we choose like 10, right? 10 minus 2 is 8. 10 minus 2 is 8. 8 plus, and then 10 minus 7 is 3. 8 plus 3. This is interesting. This is interesting. Oh, no, you know what? My fault. I'm tripping. I was thinking this was an inequality. Okay, so no, that's, of course, 10 would not work. 10 would not work because we're only concerned with the 7. So x is 7, but this is actually what threw me off. All right, so your solutions are 7 and 2. Basically everything between 2 and 7 is included. So one way we could also write this is we could write 2 is less than or equal to x, which is less than or equal to 7. because in this interval, 7 is not included. But we just proved that 7 is, in fact, a solution. So when we combine the answers, basically, we say, okay, in this interval, 7 is not included. But then over here in this interval, 7 is included. So when we write our answer, we could write it like this. 2 is less than or equal to x, which is less than or equal to 7. So x is 2 and 7 and everything in between. All right? And this is using the table method. All right? So even though we rejected the 2 when it was in this interval, we accept everything that's in here because we got an identity. And when we get an identity, that means that all solutions in this interval are good. But then over here, we found that x is equal to 7. And we even check it. You know, when you check it, you find that it works. All right? So again, this is just another example. I did another example of a double absolute value equation. This is another example, but these require practice because there's a lot of steps. There's a lot of ways to get caught up. I mean, even in my work, I got caught up. You know, it happens to the best of us, right? So these take practice. But you can use this video as a guide and then go get some practice. Ask your teacher, ask your professor for more example problems for you to practice with so you can master this skill. Or just go online and just, do a Google search of worksheets with absolute double absolute value equations. All right. And so you can master the table method. And then maybe you want to, then if you apply the original method or the other method where you're just solving for the absolute value and then you do it again. So you end up with 4 equations. Then you can compare and decide which method you want to implement. All right. So I appreciate you watching. Follow us on Instagram. We also have content on Instagram as well. So follow us on Instagram at AllThisMath and go get some practice. And I'll catch up with you on the next video. All right. Peace.